Block design development. We will extend the story and further examine how we create the structure by isolating the individual model. We create the entire structure within the context of the model. Let's briefly see what tasks we have. Here we have a skeleton body, which is a block. We have the block skeleton out of the whole main skeleton. And now we have to decide how we will construct this block, how we will fill it with structural content. We see that we need to have a metal structure that holds everything together. We will first construct the metal structure. Then we will construct a cabinet from wood panels. Next, we finalize this structure by putting together the tabletops, as well as the structure that holds the decorative glass and the decorative handle that we will screw to the structure. All these elements must be synchronized with each other, so that when assembling the structure, they fully match the synchronized parts of the structure. How can we create such a structure using the tools provided by Inventor? One of the model bodies from the main skeleton body. Construction begins. An additional plane of symmetry is created, which we will use in the construction. We reduce it a little. For the construction context, we have the opportunity to call all the necessary additional elements, bodies, sketches. In this case, we need this sketch and a few more variables that are in the main skeleton design. Variables appear and figure in our model. In further construction, bodies are constructed that describe the metal structure. The easiest way to do this is to use the woodwork for Inventor feature and make one of the bodies transparent. We click on the sketch in the side projection. The side profile will be 100 mm high and 50 mm wide. Cold-rolled profile and its position coincide with the point at the top. This establishes a constructive relationship. Another identical profile, one side is equal to the other side. Another side is equal to yet another side. We ask that it coincide with the bottom. It is a point-to-point comparison. Completed profile position. Rotates in space, turns off the sketch. Next, two bodies are stretched from one plane to another plane. A new body is generated. Add additional legs that will indicate the place for the cabinet in the structure. To do this, you need to stand on the bottom of the sketch and indicate which angle coincides with another angle. Profile width 20 mm. Next, a new volume is created that extends to the specified location where the extra leg will be. The obtained volume is based on the principle of reflection through the plane of symmetry. A solid object is reflected through a plane. This results in a future structural skeleton for a metal structure. We continue to work with the metal structure. First of all, the volume is selected, which is only necessary for the metal structure. In this situation, it is said that there is 31, and here it is 32. Next, it is described that the entire frame construction is separated into a separate compound in which we will design the future frame. For this, the bodies that are needed for such a construction are marked and we say that a component is made from them. Name, Block 2. The location is indicated. Optional directory location. We give it a reference glass component. Next, the component in which we will construct the entire structure is created. The block is made transparent to make the construction more visible. And to the creation of a metal structure. Let's take advantage of the inventory and complete the outfit. An ISO profile with a channel is required. Specify which profile is required, 150 profile size. We turn the profile 180 degrees and align it with the point. We perform the same action with another profile. The position is selected based on the baseline. This way we get the position of the next profile. Similar actions are performed with a rectangular profile. 40 and 20 measurements are used to make the legs. Adjust and do exactly the same with the edge. The orientation is adjusted, and the base point is selected. In this way, the entire structure is covered edge by edge. Everything is repeated on the other side. The main metal structure is completed, the main skeleton is extinguished, and construction continues. Next, we cut the elements on this plane. The other element is also cut at this plane. The ends do not quite match, they should be cut straight. So, I use the software option and indicate that I want to cut to exactly this point. This is how we repeat the steps. We have a basic structure that needs to be dressed up with additional elements. After placing them, it will be possible to make reinforcement into one block. We need legs and structural elements that will support our future cabinet, which will fit in the gap between the two metal legs. We use woodwork for Inventor features for this. We choose 60 mm from the edge, then the other leg is also 60 mm from the edge. Then we add the legs, which we can also make ourselves. Only leg placement is now displayed. In one plane, then you need to help from these sides and must go through two axes. This way they all appear in their places. The legs are connected to the planes. However, if we want to change the position of the legs and put a distance of say 120 mm. However, we can see that the required holes are not cut for this element. Therefore, we use the features of woodwork for Inventor and indicate where we want the holes to be cut. After turning off the component, we can see where the hole is. If we want to change the position of the leg, I will say in this case to go back to 60 mm. We can see how the hole and the leg change their position, depending on how the position of all geometric elements changes. Construction verification. In the structure, there is a place where the structure is verified. A column with a bracket on which the entire lighting system hangs, and it is necessary to check whether the structure is working and to evaluate the aspects. The estimated weight is approximately 80 kilograms. We open the structure separately and go to the module, which is called the analysis of frame structures, and during it, the system automatically determines what structural elements are included here. When creating the structure through the frame generator, the connections between all the elements of the structure are automatically determined. The necessary loads and bracing must be set up, and the analysis performed. According to the determined force of gravity, we draw where the reinforcement is. We help the first fixed mount. The second support is a floating support. We consolidate the construction, which is chosen in the whole context in a different direction. We repeat the steps and orient her. We set up another floating support and accommodate the loads. The load is about 80 kilograms, increase to 100 kilograms and add the necessary forces. Which affect this construction, where we know that 4 points are spread over 4 points, 25 kilograms each, and here we have 2 beams, which are 25 kilograms. At the point, they divide into 2 loads. This works out to 12.5 kilograms or 125 newtons. We repeat the force loading in another place. Adjusts the magnitude of this force as it is. 25 newtons. And this structure also experiences loads. The model is ready for calculations, simulation is performed. We can see how the structure deforms. But we can identify various characteristics. It is possible to analyze the structure, what deformations are occurring. In this case, we do not make structural changes, but if necessary, we can change the parameters of the structure, change the height of the profile, change the support methods, and get the necessary real results to analyze the structure. And adapt it accordingly, taking into account the loading conditions.